Hello and welcome everyone. We're happy that we're all together again. This is a special tutorial as we will start today our first step in the practical design of the lighting systems on the software which we will work on. And for that purpose, we will work on a strong and widely used software for the lighting system design, which is called the DiaLUX. So DiaLUX is a software which enables us to construct any lighting system design for any type of project with higher flexibility and many options, so we can use it to produce a strong lighting system design, as we will know on the next tutorials. So let's go ahead. First of all, we need to know how to download the DiaLUX software. And for that purpose, I have provided for you the downloading link, which you can access easily to download the DiaLUX software. Here you can find the installation link in that file. So this is the installation link. You can copy it and paste it in your browser. So when you paste the installation link, this website will appear to you. This is the official website for the DiaLUX software. And now we will press on download DiaLUX. Then as we need the latest version of DiaLUX, so we will go down. And here we will find DiaLUX 4.13. So this is the version which we will work on. Here we press on download DiaLUX. And then it tells you that the DiaLUX will start download. So we will find here the DiaLUX is downloading, and now as I have downloaded DiaLUX before, so I'll cancel this download, and for you, you will continue the downloading until DiaLUX finish the download, and then after the download finishes, we need to install the DiaLUX version which we have just downloaded. So this is the version which we have just downloaded. All what we need is to hit it with double click, and then we press next, and then next. But as I have downloaded the DiaLUX before and installed it, so I don't need to install it again. But for you, you will continue the installation. So for me now, I'll press on cancel. And yes, this is because I have installed it before. But for you, you will continue the installation, as the installation process is very easy. And once you finish the installation, you need to open the DiaLUX software. So you can search on your PC by typing DiaLUX, and then this icon will appear for you. This red icon, which is named DiaLUX. So this is the shortcut of the DiaLUX software. Or you will find this icon also on the desktop of your PC. So anyway, you can find it on your desktop, or you can search for it on your PC. And now to access the program, we easily press double click on DiaLUX. Here the program is opening. And here this is the initial window of the DiaLUX software when you open it, and it asks us now if we need to work on an interior project of the indoor lighting system, or we need to work on an exterior project for the outdoor lighting system, or we can also work on a straight project, or if we need to open the last project, and so on. So we need now to work on an interior project as we are illustrating the interior lighting system, and for that we press on new interior project. And now we need to take an overview on the DiaLUX software to be familiar with it. And here we have 5 main tabs on the bottom. You can see we have the tab project, the tab objects, the tab colors, the tab luminaire selection, and the final tab output. So those are the main tabs of the program, and using them we can handle most of the parts we need in the lighting system design. And for the first tab project, it's responsible for any order we need to perform in the project, for editing the project, or for example to delete any object, or if we need to modify any object in the project. And then for the second tab objects, it's responsible for the furniture that we can insert inside the room to make the design at which, as we can insert some furniture for the design to simulate the reality of the room nature with the furniture parts. For example, we have the indoor furniture. Here if we press on it, we can find that we have office accessories. Here the office accessories are some accessories like the computer, the painter, the flip chart, and so on. So those are some accessories. And also we have the furniture. So if we press on it, we will find that in the furniture we have the beds, we have the shelves. We can select any one of them or any shelf of them. And also we have the chairs of the different types. So all of those are some accessories or some furniture that that we can insert inside our room, and also we have the tables and so on. So we have different types of the tables or different type of furnitures. So we can say that generally the object tab is a tab that is responsible for the furniture that we can insert inside our room to make our design a more real one. Alright, now for the third tab, which is the color, we can access it, and we will find that it's responsible for selecting the colors of the place that we are making the design at which. And here if we go up, we will find that we have outdoor colors and we have indoor colors. So the outdoor, this is if we are working on an outdoor project, and for the indoor, this is if we are working on an indoor project. So suppose now we are working on an indoor project. Here we will find that we have the colors for the floor and the colors for the ceiling, for the windows, for the furniture, for the doors, for the walls. Here if we open the floor colors, we will find that we have the concrete color or we have the wood color. So if we go down, we can select the ported floor, here it will have that color, or we can select the strip flooring, here we will have those colors which we can select any one of them. And if we go down, we will have also the ceiling colors, so those are the colors of the ceiling which we can select one of them, and also for the windows, so we can insert a window or we can insert the color of the window we have, or for the furniture color. So if the furniture color is one of them, we can select it. And for the doors also, if we have a door that has a color, we can select it, and so on. So that's for the indoor colors, and we have by the same way the outdoor colors. If we select the outdoor, we will have the outside doors and the floor colors and the roof coverings and the walls and so on. Very good. After that, the next tab we have is the luminaire selection tab, and using this tab we can select all the luminaires we need in our project. For example, if we are working on a project on a building at which we use 4 types of luminaires, 2 spots for example and 2 fluorescent luminaires for example, at that case it's recommended to insert all the luminaires in our project one time, or at one time we insert all the luminaires we need, and once we have added all the luminaires we need in our project, they will remain added in our project and we can choose any one of them at any time we need. And to add the luminaires inside our project, we easily press on luminaire selection, and then you can see we have 3 options for selecting the luminaire. The first 2 ones, which are the DiaLUX catalog or the luminaires catalog, they are related to the catalogs of the company which we are working on. And the third option is related to the codes or the files that the luminaire company is producing. This is because any luminaire company can provide us with one of 2 options to select the luminaire. The first one is the catalog of the luminaires, and this catalog is the program that we install. And once we install the luminaire catalog for the company, it will be added to the DiaLUX software automatically. Like the Philips catalog which we will work on, it's a software that we will install, and then all the Philips luminaires will be added to the DiaLUX software. So the company catalog is the first option which we can choose. And then the second option is the files or the codes. If the company has no catalog, this is in case of the company has no catalog. So instead of the catalog, it has a code or a file for each luminaire, which is called the plugin. And if we need to insert a specific luminaire, we will add this plugin or this code to the DiaLUX software using the third option, which is the luminaire files. Very good. So what we want to say is that the first 2 options for the DiaLUX catalogs, those catalogs are for the companies that we can work on their luminaires. So there are many catalogs, but those catalogs are not installed. So if a catalog is installed, it will appear in the first, and under it there is a separation line that separates the installed catalogs from the uninstalled catalogs. So for me now, as I haven't installed any catalogs, so all of those are uninstalled catalogs. But as we will learn later, we will learn how to install the Philips catalog, so it will appear the first one, and under it there will be a separation line, and under this line there will be the uninstalled catalogs. Very good. Now the final tab we have is the output tab. And using this tab, we will pick all the outputs we need from the program, like the average lux we have for each room, or the summary of all of the parameters we have got of the room, like the number of luminaires used, or the light loss factor, or the U-node factor, and so on. More than great. So that's about this tutorial at which we took an overview on the DiaLUX software, and on the next tutorials we will continue working on it to learn how to implement a full design for the lighting system. Hope that's it clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we are all together again. In this tutorial we will continue illustrating the lighting system design practically using the DiaLUX software. If you remember, in the previous tutorial we took an overview on the DiaLUX software to know its main tabs, and now we will continue exploring the DiaLUX software to be ready for any lighting system design. First of all, we need to know how to set the general settings of the program, as there are some general settings that we set to be applied on all of the parts on the project, so we need to know how can we modify those settings. And to do so, we go to the File tab. Here we press on the File tab, and then we press on Setting, and then we press on General Options. As you see, we have here some tabs which we can work on. The first one is the Standard Values tab. And using this Standard Values tab, we can set some standard values related to the project setting. And those values are set now by default according to the United States standard, so we can change the country standard. Here, if we drag this tab down, we will find that we have some other standards according to some other countries like the Denmark, the Deutschland, Italy, and so on. So if we changed the standard, for example, to the United Kingdom standards, you can see the values have been changed, and if we changed it to be according to the Denmark, for example, you will find that the values also, or the setting values, has been changed. So according to the country we are working on, those values can be changed. But for us now, let's set it back to P, here the United States. But the important thing is that those values can be set manually also according to your country standards. As here we have the room dimensions also, its length, its width, its height. So it's up to you. You can change those values as you need, or you can work on the default values that the program set. But those values also of the room dimension is not some standard values, as for the practical design each room will have its own dimensions. So for each room when we work on it, we will enter its dimension according to the actual design of the room. Very good. Then the next part we have is the reflection factors of the room. And it's the color reflection index which we illustrated before, if you remember, as according to the color of the room there will be a specific index of the room which is the room reflection index. And here the standard value for the ceiling reflection index is 80%, and for the walls it's 50%, and for the floor it's 20%. And also we will set those values of the ceiling reflection index, the walls, and the floor as default. So we will set those values as default, or we will not change them. And then for the working plane, which we illustrated before, the standard height of the working plane is 0.76 meter. And this is assuming that there is a working plane like the office or the pit, for example, and the height of this office or this pit is 0.76 meter. So this is an accepted value also, and we will set it as default, or we will not change it. And also for the working zone length, which is related to the area that we need to focus on the illumination process, we will set it to be 0.5 meter as default also. So 0.5 means that we need to focus on the area which starts after 0.5 meter from the walls of the room, or we will take an offset of 0.5 meter, and after this length we will start the illumination process. But the important note here is that although those values are general, we can easily change them for any place we are working on. So they are some default values, but we can change them. As you see, I can change the height of the working plane to p or 0.5 meter only, for example. So it's up to you to change those values or to set them as default. And this is because not all of the rooms have the same case. For example, for the corridor, the working plane is 0. This is because there is no furniture to consider its height in the corridor. And also the wall zone is 0. This is because we need the illumination process to include all of the room from the starting of the wall with no offset. Alright. After that, for the maintenance factor, it's set to be 0.8 by default, and this is also an accepted value as we illustrated before, so we will set it as default. And by that way we can enter the values we need, but those which we just illustrated are the important factor which we need for now. Very good. Now the second tab we have is the global tab, and using this global tab we can set also some parameters related to the project, like the project directory, which is the initial path that the project will be saved at which. So this is the default path at which the project will be saved, and we can change it also to the path we need. So we can change the directory to any path we need. Here if we press on this tab, we can change the path to anything we need. For example, I can select the documents folder to be the initial path at which the project will be saved automatically, and then I press OK. So all of those are options up to you. And also we can save each project individually to the path we need, as it's not necessary to save all of the projects to the same path or the same folder in your computer. All of that is up to you. And also for the program language, we can change it as what we want, but for now we will set it to be English. Here you can see we have many language. You can set it to the language you need, but for us now we will select it to be English United States. And then the important settings now are the units we need the project to be set on. So we will set the dimensions to be the SI unit, like the meter or the centimeter. And if we drag this tab down, you will find that we have the metric units, which is the SI units, the meter, the centimeter, and so on. And also we have the imperial units, which are the feet, the inches, and so on. But for us, we will work on the metric units, the meter, and the centimeter. And also for the lighting units, we will use the SI units, which are the lux and the candle per meter square. Here you can see we have the European units or the SI units, the lux, the candle per meter square, and also we have the imperial units. But for us, we will unify our working operation to work on the SI units. And finally, for the automatic saving, we will find the software to save the project automatically each 15 minutes. So we can change it, for example, to be 60 minutes. So that's about the automatic saving, and we can save the project manually also each time we need. So the project is saved automatically or it's saved manually. Very good. Also, we have some other settings, but those are the important ones for us now, the standard values and the global settings. And now we press OK. After that, the next step we need to perform is to export the architectural layout that we will make the lighting design for which. This is because the luminaires are inserted on the architectural layout, which is represented in the AutoCAD design. And this AutoCAD design has an extension of DWG or DXF. So for the AutoCAD design, we need to insert it in the DiaLUX software to work on, and its extension, as we said, will be DWG or DXF file. And for that purpose, I have provided you with an architectural layout for a hospital that we will work on as an example to make the lighting design for some rooms of this hospital. And to insert this CAD layout or this DWG file for this hospital, we easily press on this tab, which is Load DWG or DXF file, and then we press Next. And here you can see this is the hospital CAD layout which we need, and its extension, as we said, is DWG. Here we select it and press Open It's loading now. After that, we press next, and then next, and then next, and finish. Very good. Now we need to start exploring our hospital layout to be familiar with it, and for that reason we need to zoom out a little bit in the program, and to zoom out we easily use the scroll of the mouse. So I use the scroll of the mouse, you can see I zoom out, or if I need to zoom in I use the scroll also, but we scrolling down now. So if we scroll down you can see I'm zooming in, and if we scroll up you can see I'm zooming out. Here zoom in or zoom out easily using the scroll of the mouse. And also we have another method to zoom in or zoom out in the program, and this is by pressing on this magnifier. Here you can see we have the magnifier tab on the DiaLUX software. If I press on it you can see the mode is changed to the magnifier, and at that case if I need to zoom in I easily press a left click, and while keeping pressing left click I move with the mouse to right or left. Here as you see, if I move to the left, I'm zooming out, and if I move to the right, I'm zooming in. So you can see I press a left click and move to the right and move to the left. So when moving to right and left while I'm pressing a left click, here I can zoom in or zoom out, and also by using the scroll of the mouse. So anyway, this is the method at which you can zoom in or zoom out in the program. Also, if we need to select any object in the project, at that case we need to get out of the magnifier mode to the selection mode. And to go to the selection mode, we easily press on this arrow tab here. You can see we have the select object mode, or this arrow tab, I press on it. You can see we have changed to the selection mode, and by that arrow we can select any object by pressing a left click and drag. So you can see we have this rectangle, which is the rectangle that will select the objects, or I press also a left click and drag to the left. So when pressing a left click and drag to the left or drag to the right, this is the way by which we can select any object we need. So that's about the selection mode. And then the next mode we have is to move in the drawing. And to move in the drawing, we easily press on this hand tab. So this is the move mode on the DiaLUX software. We press on it, and easily we press a left click, and while pressing a left click we move with the mouse. So you can see we are moving in the drawing as what we need. And also we have another way for moving in the drawing. This is by pressing on the scroll, and while pressing on the scroll we can move with the mouse. So anyway, we press on the scroll, or we use this hand tab and press a left click and move in the drawing. Those are the ways using them you can move in the drawing. And finally, the final mode we have is the rotate mode. And this is to rotate the design we have. But if we need to rotate the design, this needs the design to be in the 3D mode. And to make the design in the 3D mode, here we go to the selection mode again and press a right click, and then press on 3D standard view. So you can see we have moved to the 3D mode. And now to rotate the object we have, we select those two arrows, which is the rotate view mode. Here we select it, and then press a left click, and then we rotate the object we have, or we rotate the room we have. So by that way we can rotate the object we have, or we can zoom in and zoom out. Very good. Now let's close this tab by pressing a right click and then close window. Here we have flipped back to the 2D mode, not the 3D mode, and that's it. More than great. So that's about this tutorial, at which we continued exploring the DiaLUX software, and on the next tutorial we will continue that step to make a complete lighting system design. Hope that's clear right now. Thank you for watching, and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial we will continue illustrating the lighting system design practically using the DiaLUX software. So let's go ahead. If you remember, in the previous tutorial we have added the actual layout of the hospital on the DiaLUX software, which is the CAD design represented in the DWG file. And now we need to know how can we insert the required luminaires in the design to make the lighting system. But at first we need to install the catalog, which we will export its luminaires in the DiaLUX software. As we said before, we will work on the Philips catalog, so we will install the Philips catalog now. And for that purpose, I have provided for you the Philips catalog as a program, as you just need to set up it. So we can access the Philips catalog folder now. And then we press double click on this setup exe icon. But for me, as I haven't installed the Philips catalog before, so I'll press on cancel. And for you, you will press on next and next to finish the installation, as this program installation is very easy. So you will follow the installation steps very easily. But for me, I'll press finish now. And then I'll go back to the DiaLUX software, and at that point the next step we need is to explore the CAD layout we have. This is because if we need to make a correct lighting system design, we should understand the design that we are working on very well. So we should know the type of each room, as according to the room type we specify the amount of lux that this room needs. So let's explore the hospital layout we have. This is a floor of the hospital. We can explore it now by zooming in. Here you can find we have a waiting room. So this is a waiting room. We knew its type from the furniture that exists in the room. Those are some sitting chairs, so the patients can wait on those chairs. And also we can have this is an examination room, or this is a clinical room in the hospital. And if we go there, we will find that this is another examination room. We knew its type also from the furniture that exists on the room. Here we have a bed, and at this chair the doctor sat, and at those chairs the patient sat. And also if we go there, we can find that this is a small bathroom. Also we knew the type of the room from the furniture that exists, or from the objects that exist in the room. Here from those objects we can know that this is a bathroom. And also if we go there, we will find that those are some stairs, as this is the shape of the stairs. And when we find an arrow going up, so this means that those are some stairs. And also we can go there a little bit. Here we find that this is another bathroom. And if we go there also, we will find that this is another clinical room, or this is another examination room, and this is another clinical room. You can see we have another bed at which the patient can relax and the doctor can examine him. And also we have here, this is a waiting room at which the patients can wait until they enter to the examination room. And also we will find that those are some bathrooms. And if we go up a little bit, you can see this is a small reception, and this part is for conference. So at this reception the visitors can sit, and also at this table or at this conference table some people can sit. So what we wanted to say is that according to the furniture that exists on the room, we can estimate the type of the room or the use of this room. And also this is another one. And if we go there, you can see those are some rooms for the patients, as we have here some beds, and then the patients can relax. Or this is the branch at which the patients can sit, so the patients can stay at those beds or at those rooms on the hospital. And also if we go up, you will find this is a branch, or this is the total branch for the patients at which the patients can stay on the room. Very good. So this is a quick overview on the floor of the hospital we have, as according to it we can make our lighting system design for each room of them. And now the next step we need is to select the room at which we will make the lighting design for. And here we can go down, for example, and we can select this waiting room. So we can start our lighting design with this waiting room. And now the next step after detecting the room which we will work on is to specify this room. So we need the DiaLUX software to recognize that this is the room which we will work on. So what we will do now is to press on insert new room. And now it asks us to enter the length and the width and the height of the room. So we need to enter the dimensions of the room. So to do so, we will go to our room we have. Here we go to the waiting room, and then we press a right click, and then we press on draw rectangle. So by drawing a rectangle, we will specify the borders of the room to specify its length and width. So we will go here, and we will start from this point, for example, and we drag up. So we specify the first point and we drag up to specify the last point. Here we can zoom in to specify the last point we have. And here we can specify it to have those borders. Very good. So by that way, we have entered the length and the width of the room. You can see the room length is 6.2 meter and the room width is 4.4 meter. And for its height, we need to enter it now. So the default height is 2.7 meter. But if we need to enter the correct height of the room, we can get the architectural information for this hospital layout. And from the architectural information for that floor of the hospital, we find that the total height of this floor is 4 meters. And there is a suspended ceiling on about 0.75 meter. And this means that the luminaires will be suspended on a length of 3.25 meter from the ground. And for that reason, we will specify the height of the room to be only 3.25 meter. So we go to the height and make it 3.25. So that's for the height of the room. And as we said, this 3.25 is 4 meter minus the suspension height of 0.75 meter, which is the height at which the luminaires will be installed. Very good. So that's the way we have detected the room dimensions, its length, its width, and its height. And after that, we need to insert the required luminaires. And for that, we will open the Philips catalog, which we have just installed. So we press on luminaire selection, and then we press on DiaLUX catalog. As you see, we have the Philips catalog to be the first one. And then there is a separation line between it and the other catalogs. And this means, as we said before, that the installed catalogs are the ones above the line, while the catalogs under the line are the not installed catalogs. And for that, we will choose the Philips catalog. Here we press on Philips lighting. As you see, this is the window from which we can choose the required Philips luminaires we need. But to select the required luminaire, we need to follow some steps for the selection from this window. First of all, we select if we need an indoor luminaire or outdoor luminaire. As you see, we have here two options, indoor or outdoor. We select any one of them. This is because the indoor luminaires differs from the outdoor luminaires. And for us now, we will select the indoor luminaires as we are working on an interior project. And then for the selection, there are some paces. According to them, we can select the luminaire. So we can select the luminaire according to the family code. And using this family code, we will enter the code of the family of this luminaire, as each group of luminaires has a specific code which we can specify or select the luminaire according to this code of this family. For example, the fluorescent luminaires have a general family code, and the spot luminaires have another general family code, and so on. So that's for the selection according to the family code. And here we can try if we select family code and then we go down. You can see all of those are the different family codes we have. We can choose any one of them, and then we select the housing, the distributor, and the specific luminaire we have, and that's it. So this is a random luminaire which we have choose using the family code. And then we have another page of the family selection, which is the family name now, not the family code. And the family name is the selection of the luminaire according to the name of the luminaire family, as each group or each family of luminaire has a name. And according to this name, we can choose the group of this luminaires or the family of this luminaires. So we can say that the difference between the family code and the family name is that. In the family code, we select the family of the luminaires according to the code of this family, while in the family name, we select the family of the luminaires according to the name of this family. Here we can choose family name, and then we go down. You can see we have many family names, and if we know the family name of the luminaire we have, we can select it and choose the luminaire we need. Alright. After that, the next selection we have, or the next piece of selection, is the family category. And the family category is the selection of the luminaires according to the category of this family of luminaires. And the category is based on the type of the installation of the luminaire. Is it a surface luminaire or a suspended mounting luminaire, for example, or a wall-mounted luminaire, and so on. So we can see here, we have the receive mounted, we have here the surface mounted, we have the suspended, and so on. So according to the installation type, we can choose the luminaire. Here, this is according to the family category. And after that, the next selection phase is the gear. And the gear is the type of the coil or starter that is used to start the lamp or the luminaire. So we select the luminaire in that phase according to the palace type. Is it an electronic palace or a magnetic palace, and so on. And finally, the final selection phase we have is the lamp category. And by that selection option, we select the type of the luminaire we have directly. Is it a fluorescent luminaire, a halogen luminaire, a high pressure sodium, for example, and so on. So if we go down, you can see we have the high power LEDs, we have the incident lamps, we have the induction lamps. Here on the upper we have the fluorescent, the halogen, and so on. So by that selection option, we select the type of the luminaire we have directly, and you can try it. More than great. So that's about this tutorial at which we started constructing our lighting system design. Hope basically right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we'll continue illustrating the lighting system design practically using the DiaLUX software. So let's go ahead. If you remember, we ended in the previous tutorial with illustrating the different selection phases in the DiaLUX software. According to them, we can select the required luminaire. And now we need to select the required luminaire which we will use in our lighting design, which we will use for the lighting design of the waiting room, which we have selected before. And for that, we can select a fluorescent luminaire. So the fluorescent luminaire will be a suitable one. And also let's select it to be a fluorescent luminaire 4 times 18 watt. So we need a luminaire which includes 4 lamps, and each of them is rated 18 watts, which means that it's a TLD lamp, not a TL5 lamp. And also its length is 60 centimeter as it's 18 watt. And to select the required 4 times 18 fluorescent luminaire, we can choose it according to the family code. So here we select the family code as you see. And for that, the code of this fluorescent luminaire is TCS. So we type here TCS. And here as you see, we have many types under the TCS. Here all of those are some family codes. So let's select the first one, TCS 097. But as you see here, we have no 4 lamps, so all of those luminaires have only 1 lamp or 2 lamps. Here 1 times TLD, 18 watts, and here 2 times TLD, 58 watts, so we have no 4 lamps in this code or in this family code 097. So let's change the selection option to be the second one, here TCS 098. And that's it. You can see we have here the required 4 times TLD 18 watts. So this is a TLD luminaire and its power is 18 watt. But you can see here we have 3 boxes, one for the housing and the second one for the distributor and the third one for the number of luminaires. Here this one for housing, this one for distributor, and this one for the number of luminaires. So the first one or the first box is used for the housing or the frame at which the luminaire will be installed on, as there are many types of frames or bodies at which the luminaire is installed or set. And also we have the second one for the distributor, and we have illustrated the distributor before if you remember. It's responsible for reflecting the light output of the luminaire, so it increases the area at which the lighting is spread on. And for that we have different types of the distributors. As you see, we have the type C3 or the type L or the type ML. And finally, the last column, which is the number of luminaires, it's responsible for expressing the number of lamps we have inside this luminaire and the power of each lamp of them. Very good. Now we have selected the number of lamps to P4. But now for the distributor, let's select it to PC3. And for the housing, the final option remaining for us is this one, TCS 098. That's it. You can see now we have this 60 x 60 fluorescent luminaire. and this is the amount of lumens or flux we get out of it, which is 1350 lumens. And on the right here we have the polar curve of the lumineer, and the polar curve represents the shape of the lumens distribution of the lumineer. So we have here two curves, the green one and the red one, and they represent the shape according to which the lumens of the lumineer is spread on the surface or the working plane of the room. And as we said before, the lumens distribution depends also on the distributor type, as one distributor can make a larger reflection, so it spreads a larger amount of lumens, and another distributor has smaller reflection, so it spreads the light less. So let's see now how the polar curve changes when we change the distributor type. Here let's select the distributor of the type L. You can see the polar curve has been spread more, as the L-type distributor makes the light to be spread on a larger area than the distributor of the type C3. And also we can select the ML to see it, and by the same way the ML distributor has a different spread range. So we say that the polar curve is responsible for the shape of the lumens distribution, and this shape of the lumens distribution is affected by the type of the distributor we use on the lumineer. And also we have another factor here, which is LOR, or light output ratio, and the light output ratio is the percentage of the light that is getting actually of the lumineer to the lumens that the lumineer should give us theoretically. This is because of the actual amount of lumens is not the amount of lumens we get from the datasheet of the lumineer. This is because there are some losses of the lumens output of the lumineer, so we get this light output ratio to represent the ratio between the actual lumens falling on the surface to the total lumens that the lumineer should give us in the ideal case. And also you can see this distributor of the type ML gives us a light output ratio of 0.5, while if we change it the distributor type to P of the L type, you can see the light output ratio increases to P 0.63, and by the same way, if we change it the distributor to P of the type C3, you can see we have the largest light output ratio to P 0.68. So what we wanted to say is that the selection of the distributor is an important thing, as according to it the polar curve changes and also the light output ratio. Very good. Now after detecting the required lumineer, we can add it to our project, and to add our lumineer, here we can drag this tab up, and then we increase the length of this tab, and here we can press on add. This is to add our lumineer. Here we press add, and that's it. The lumineer has been added successfully. Now after adding the required lumineer, we press on close, so we don't need the Philips catalog much more. And now we need to insert our lumineer, so we press a right click and then insert lumineer, and then we have many options of the insertion, the field arrangement, the individual arrangement, the line arrangement, the circular arrangement. So those are the options that we had illustrated before. And for our room, the field arrangement will be a suitable one, as this is an official room, so we don't need an aesthetic shape, or we don't need an individual arrangement, or we don't need also the line arrangement. This is because the width of the room is not a smaller one, so it's not a corridor. And for that we will choose the field arrangement, and that's it. You can see this is the lumineer which we have just chosen from the Philips catalog, and here its code is TLD 18 watts. And its luminous flux is 5400 lumen, which is the actual flux falling on the working plane. And for the correction factor, it's the factor which specifies the losses of the light output of the lumineer due to the dirts on the lumineer surface. So we cannot get the benefit from all of the lumineer lumens, as there are some dirts on the lumineer surface due to the dusts or the dirts on the lumineer. And for that reason, we put the correction factor practically to P 0.8 instead of 1. So let's change it now to P 0.8. And this is to clarify that there are some losses output of the lumineer. Very good. After that, we have the total power of the lumineer also. So the total power of this lumineer is 88 watt, and that's it. Now we can press on insert. Very good. You can see we have the luminaires inserted on the room. Here we have a total amount of 8 luminaires represented in 4 rows. Here 4 rows, and each row has 2 luminaires on it. But we need now to know if this is a correct design or not. So we need to know if this design achieves the required lux that the waiting room needs or not. And we will check that on the next tutorial. So let's pause this tutorial. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will continue illustrating the lighting system design for the waiting room we are working on. If you remember, in the previous tutorial we ended with inserting those 8 luminaires, but we didn't check our design, or we don't know now if this is a correct design or not. So we are not sure now if those 8 luminaires achieve the required amount of lux or not. And the first step to get a correct design is to detect the required amount of lux that our room needs. And for that purpose, we will use the international code to detect the required amount of lux for our design. So we will work globally according to the IEC code, as it's a supported design all over the world. And for that purpose, I have provided for you the IEC code or the lux required for any types of room according to this IEC code. So this is the PDF for the lux required for each type of rooms according to the IEC code. Here we open it by double click on it. Very good. Now as our design is a waiting room, so we need to search for a waiting room on this code to get its corresponding lux value. And for that we can type on the search bar waiting and press enter. That's it. You can see here we have the waiting room under the entrance category, and its average lux value is 150 lux. So this is for the waiting rooms or for the lobbies or for the entrance halls. All of them have the same lux value or the same average lux value of 150 lux, and this is under the entrance category. Now let's go back to the DiaLUX software, and here this is the room we are working on. It's room 2. Let's rename it by a right click and then press rename. So let's rename it to P waiting room and press enter. That's it. And now what we will do is to check if the achieved value of the lux which we have achieved of those 8 luminaires is a right or a wrong value. So we can press on this calculator tab. And using this calculator tab, we can calculate all the required parameters about the room we have. And after that, we will express the calculated data of the room. But at first, here to start calculations, we press on OK. Here the program is loading the calculations. And that's it. You can see this is the 3D view of the room we have. Here we can rotate it by pressing on this rotate view. And that's it. As you see, those are the 8 luminaires we have, and this is the area or this is the volume of the room. And to get the calculated values of the lux, we easily press on this single sheet output. So we press on this tab here. Very good. Here this sheet represents a PDF file which has all the parameters we need about the room. So let's check it now. But at first we need to drag this tab here to the left a little bit. And now to view all the size of the sheet, we press on this tab here. Very good. As you see, this is a single sheet output which includes all the technical data about the lighting system that we have designed for that room. And if we go down a little bit, we will find that we have those 8 rectangles, which represents the 8 luminaire which we have. And also those numbers represents the distribution of the lux across the area of the room. And when going down a little bit, we will find that this is the length of the room to P 6.24 meter, and this is the total width of the room to P 4.47 meter. And also we have the working zone to P 0.5 meter. So you can see we have an offset here of 0.5 meter and an offset here of 0.5 meter and also an offset here of 0.5 meter. So from each wall of the 4 walls, we have an offset of 0.5 meter, which means that we start the lighting design after 0.5 meter from all of the walls of the room. And this appears very clearly here as we have no lux distribution at this area or this area or this one or this fourth one. So the lux distribution appears at this area only. as this is the working zone area, or this is the area which we need to focus on at our design. And then when going down a little bit, we will find that we have some parameters of the room, like the reflection index rho and the average lux, the minimum lux, and also the maximum lux. And finally, we have U note, or the factor which specifies the E comfort inside the room. And also all of those values are expressed on the different parts of the room, like the working plane, the floor of the room, the ceiling of the room, and the walls of the room. For example, we find the average lux, which we have got at this design to have different values on the floor and the ceiling and the walls. Here, as you see, the working plane average lux is 608, and for the floor it's 471, and for the ceiling it's 99, and so on. So each of those parts has different values of the average lux, the maximum, the minimum, and also for the reflection index, and also for the U note. But for us, the important values which we need to focus on are the average lux and the E comfort U note. So we focus on the average lux and U note, and we focus on them at the working plane of the room only, so we don't care about the maximum or the minimum lux, but we just focus on the average lux, as this is the value which should be near to the value which we have got from the IEC code. And also U note should be on the accepted range, so we see if E average and U note are as required for the working plane or not, and we focus on them at the working plane only. But the important question now is that, what is the accepted value of the average lux we got, and also what is the accepted value of U note? Here we say that E average must equal the value which we have got from the code with a tolerance range of positive or negative 10%. And this means that if the required value which we have got of the lux from the code is, for example, 100 lux, the accepted value which we will get from the program must be in range of 90 lux till 110 lux. So if the value which we have got as a result lays in the range of positive or negative 10%, it will be an accepted value. So that's for E average. And for U note, it must be larger than 0.4. So if we got U note larger than 0.4, this means that we achieves the required E comfort of the room. And if U note is smaller than 0.4, this means that we doesn't achieve the required E comfort on the room, so we need to increase it. Very good. But if we need to apply those concepts on our design here, we will find that the value of the lux which we have detected at the working plane, or the average value at the working plane, is 608 lux, while the value that we have to get is only 150 lux. So this value which we have got is very larger than the required value, so it's not an accepted value anyway. And for that reason, we need to modify our design to decrease the average value of the lux. So we need to reach the value of 150 lux or a nearer value to it. And also, if we took a look on the U note value, we will find that it's an accepted one, as its value is 0.71, which is larger than 0.4. And this means that the E comfort value at the working plane is the required value, or we succeeded to get the required value of U note. So our aim now is to modify the E average or the average lux. And for that, we will close this tab, and then we will go to the 2D mode. Here, those are the 8 luminaires we have. We can use the selection mode, and then we can select any luminaire of the 8 luminaires we have. So all of the luminaires have been selected. And now you can see we have an average value of the lux that the program will give us. And the default value here is 500 lux. And for that reason, we have got a larger value of the output lux from the single sheet output. So we can decrease it now to be only 150 lux. And then we will press on suggest. And then we will press on yes. So by that way, the program makes a suggestion for us for the required number of luminaires. As you see, the suggestion is 3 luminaires only. But we cannot rely on the program suggestion, as we need to check if this design is a correct one or not. And for that reason, we make the calculations again as we have made some modifications of the design. So we press on the calculator again, and then we press on OK. So the program is calculating the calculations again according to the modifications. Here, as you see, we have those 3 luminaires only. We can see them. And then to see if this is a correct design or not, we can press on the single sheet output again to see the results. And then we press on view full size, and then we drag down a little bit. You can see we have here an average lux on the working plane of 232 lux, so this is still a larger value than the 150 lux we need. And for the U note it's 0.6, so it's an accepted value. But for the E average we need to decrease it. So we close this tab again, and then we go to the 2D mode to go to our design, and then we go to the selection mode and press our luminaires. Here we have 3 luminaires, which gives us 230 lux. So we need to decrease the luminaires to decrease the average lux we have on the working plane. And for that, we can decrease this number of luminaires per row to make it only 2 luminaires. And then press yes. And that's it. Here we have 2 luminaires only. And we will repeat the same steps to start the calculation again after making the modifications. And press OK. And then we can press on the single sheet output, and then press on view full size and go down. Very good. You can see we have here 160 lux. This is the average value of lux, and for U note it's 0.59, so U note is larger than 0.4, and for the E average it's an accepted value also. And this is because the 10% of the tolerance of the 150 lux is 15 lux. So the maximum total lux is 165 lux, but here we have got only 160 lux. So this is an accepted value. Very good. So by that way, we have managed to make our design as what we want. Here, this is the distribution of the lux, and this is the average lux we need. Now we can close this tab and see our design in the 3D mode. Here, those are the 2 luminaires which we have for our waiting room. So those are 2 luminaires, and each of them is 4 times 18 watt fluorescent luminaire. And by that way, we succeeded on implementing our first lighting system design for the first room we have, which is the waiting room. Hope that's clear right now. Thank you for watching, and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we will illustrate the lighting system design, but for a different room in our hospital layout to understand the different designing cases which we can face while making our lighting system design. So let's go ahead. If you remember, in the previous tutorial, we finished the lighting system design for this waiting room, at which we used 2 fluorescent luminaires, and each of them is rated 4 times 18 watt. And we have got the required value of lux for this room, which was 150 lux. And now let's choose another space to design its lighting system. Here, if we go up, we will find that we have all of those rooms. But suppose we need to make the lighting system design for this corridor, for example. So we have this long corridor that attaches all of those rooms to each other. So this corridor joins or make a link between all of those rooms here, those rooms on the right and those rooms on the left. So suppose we need to make the lighting system design for this corridor. In that case, we will press on Insert New Room. And then we will go up to specify the dimension of this corridor. Here we go there. And then we will press a right click and then draw rectangle. So we will draw rectangle starting from that point. And then we drag up. Here we drag the rectangle up to select the whole length of the corridor we have. So we can zoom in a little bit. And then we go there. And that's it. Here, this is the length of the corridor we have. Here we have specified all the 4 points of the rectangle for the corridor. As you see, the corridor length is 1.8 meter and its width is 34.2 meters. And for its height, this is the default value, 2.7 meter. But as we said before, we will insert the lumineers on a height of 3.25 meter, as there is a suspended ceiling on a height of 0.7 meter from the concrete ceiling, and because the total height of the concrete ceiling is 4 meters, so the suspension length will be 4 minus 0.75, which will be 3.25 meter. So we change this height to P 3.25, and then we press OK. And that's it. This is the space which we have selected its dimensions. Now we can rename it to P corridor. Here we press a right click and then rename, and then corridor. And then we press enter. Very good. Now the next important thing is to set the wall zone and the working plane of this corridor. As we learned before, for the corridor there is no furniture, so the working plane will be 0. And also the width of the corridor is small. As you see here, its width is about 1.6 meter. So it has a narrow width, and for that reason we set the wall zone also to P0. And for that we access the corridor we have, and then we press on the working plane. You can see the height, or the working plane height, has a default value. For each room we have to be 0.76, but for this corridor this is a special case, or it has a special condition to have the working zone of 0. So we set it to P0, and also for the wall zone it's 0. This is, as we said, because we will start the lighting design from the first end of the wall to the first end of the opposite wall. Very good. Here we have changed the working plane and the wall zone for this corridor to P0. And at that point we are ready to insert the lumineers we have. But for now we will use another type of the lumineers, as we need to try the behavior of another lumineer, so we will not use the previous lumineer which we have used for the previous tutorial, which was for the waiting room, which was 4x18 lumineer. So we need to try now to use a LED lumineer of the spot type. And to insert this LED spot lumineer, we will access the Philips catalog. Here we press on lumineer selection, and then DiaLUX catalog, and then Philips lighting. Then we will search according to the family code also, so we will access this LED lumineer according to its family code. And the family code of this LED lumineer is FPS, so we type here FPS, and then we will choose it to P261, so FPS 261 is the family code of the LED lumineer we have. So this is the housing, or this is the only housing of this LED spot. And it's distributor of the type C, so we can try this distributor of the type C. And for the number of lumineers, here we will select a LED spot which have only one lumineer, and we will choose it to P18 watts. So this is the LED spot which we need, which have only one lumineer, and the power of this lumineer is 18 watt. And for its polar curve, as you see, this is its polar curve, which is a symmetrical one. And this means that it distributes the light in a symmetrical way, which means that the light distribution on the right equals the light distribution on the left. So it has a homogeneous distribution of its output light on the area of the room. So that's about its polar curve. And also you can notice now we have the number here, which is 830 under the color. And here this first number 8 means that the color rendering index is 80%. So the first number refers to the color rendering index. Here 8 means 80 and 9 means 90 and so on. And the second number 30 here means that the color temperature of this lumineer is 3000 Kelvin. So what we want to say is that the first number refers to the color rendering index, and the second number refers to the color temperature of this lumineer. Very good. Also, you can see the flux or the lumens of this lumineer is 1200 lux. So this spot lumineer produces 1200 lux. And finally, for its light output ratio, it's 0.61. So those are all the required technical data about the spot lumineer which we have chosen. And what we will need to do now is just to add this lumineer. So we can drag this tab up and then drag this tab down a little bit. And now we press on add to add this lumineer. That's good. Here the luminaire has been added, and then we press on close. So we have added our required luminaire now. Now at that point we need to know what is the lux required for this corridor, and for that we need to access the International Electric Code or the IEC code for the required lux value. So let's open it. And you can see we have the first type of places on the IEC code to pay the corridor. So this is the corridor here. We can access it and we can access its required lux value. But you can see here we have two columns that we can choose the lux from them. So you can ask now which column we will use. Is it the first column or the second column to pick its lux value? Here we say that the values on the first column is the standard values, while the values on the second column are the most common values or the values that the code recommends you to use. So we will work on the second column, not the first one. This is because its values are the most recommended values or the most used values in the designs. Hence, we will find that the required value we need for the corridor is 50 lux. So we will go back to the DiaLUX software to make our design according to the required 50 lux. Now what we will do is to press a right click and then insert luminaire, and at that point we will not select the field arrangement option, but we will select the line arrangement option. This is because we need no matrix now, as we are not working on a place or on a room that has a larger width, but we are working on the corridor which has a smaller width, so we need no matrix or no number of columns and number of rows. Here we just need a line to insert the luminaires according to or along its length, so we insert the luminaires along the length of the corridor. And for that reason we select the line arrangement. That's good. Here this is the luminaire which we have just inserted. As you see, it's 18 watts and its luminous lux is 1200 and its power is 25.3 watt, and for its correction factor it's 1, so let's change it to P only 0.8. And then we will go to its mounting. Here at its mounting, we will specify the quantity of the luminaires which we have. Here the quantity of the luminaires is 103. This is according to the recommendation of the value of lux of 500 lux. So we need no 500 lux, we need only 50 lux. So we will change it to P only 50 lux. And then we will press on suggestion for the program to suggest for us a number of luminaires according to the required value of lux we need. So we press on suggestion, and here the program tells us that if we need to have 50 lux of this corridor, we will use a number of luminaires of 13 luminaires. So we will work according to this suggestion. Here we press on insert, and that's it. You can see we have those 13 luminaires. If we go there, we will find that those are the luminaires. Here along the length of the corridor we have 13 luminaires. But we cannot rely on those values of the suggestion, as we must check the average value of the lux we have got, and also we must check the U-node value. And for that purpose we will start the calculations by pressing on this calculator tab, and then we select the corridor which we have, and then we press on OK. So the calculations are made now. Very good. You can see this is the 3D model of the corridor we have. This is its length, and those are the shapes of the luminaires we have. And now to see our results, we will press on this single sheet output, and we will specify the single sheet output for the corridor, not the waiting room. And then we press on OK. So this is the single sheet output we have, and then we press on view full size width, and then we go down. As you see, we have the average lux value of 64 lux and U-node of 0.65. So U-node is an accepted value as it's larger than 0.4, but for E-average it's larger than the maximum value, as the maximum value is 500 lux with 10% increase, which is 55 lux, but this value is 64 lux, so it's larger than the maximum required value, or it exceeds the maximum value of 55 lux, and for that reason we must decrease the number of luminaires which we have used. This is to decrease the average output lux on the working plane. So we will close this single sheet output for now, and then we go to our working plane, and then we select any of those luminaires we have, and we press on luminaire, and we press on general. Here the quantity is 13 luminaires. Now let's change it to P, for example, 11 luminaires only. And then the program asks us if we need to make the changes. Here we press on yes. So you can see we have decreased the number of luminaires to be only 11 luminaires, not 13 luminaires. And after that, we need to start the calculations again, as we have changed our design. So each time we changes anything in our design, we must make the calculations again. And then we press on OK. So the program is recalculating our design. And that's it. This is the design of the 11 luminaires. And then we press on the single sheet output, also for the corridor, and press OK. Here we view full size and go down. And that's it. You can see we have achieved the required value of lux. So it's 55 lux, which is the maximum output value that we can have. This is, as we said before, the maximum value is 50 lux with 10% of increase as a tolerance. So it's 50 plus 5, which is 55. And here this is an accepted value. And also for unit, it's an accepted value as it's 0.65. So those are some accepted values. And by that way, we have designed a suitable lighting system for the corridor we have to achieve the required standard values of the lux and U-note. And here we can close the single sheet output and see this is our design which we have made. We can rotate it. As you see, those are the 11 luminaires. We can see them now. They are some recessed luminaires. So only the surface of the luminaire appears here. And also we can rotate it. So this is the total length of the corridor, and this is the shape of the luminaire from the top view, and that's it. So that's about this tutorial, and on the next tutorials we will continue making our lighting designs for different types of the rooms. Hope that's clear right now. Thank you for watching and see you next tutorial. Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we will illustrate a different lighting system design for the rooms we have in the hospital layout to understand the different designing cases which we can face while making our lighting system design. So let's go ahead. If you remember, on the previous couple of tutorials, we have designed the lighting system for this corridor we have and also for this waiting room. And now we will work on another type of rooms to make a lighting design for it. And here, if we explore this architectural layout, we can find that we have a different type of rooms here, which is this room. And if we focus on it, we will find that it looks like an office or a meeting room. So we can focus on this room to make its lighting system design. And first of all, to work on this room, we will press on Insert New Room. And then we will rename this new room here, which is room 8. So we will rename it to P, the meeting room. That's it. And then we will enter the dimensions of the room we have. So we will go to our room. Here we go to it again. That's it. This is our room. So we press a right click. And then we will not draw a rectangle. This is because this type of room is not a regular one, or it has no regular shape, but it has an extension here, as you see. And for that reason, we will use the second option, which is draw polygon. So we use the option of draw polygon if the room has more than 4 walls. And if the room has only 4 walls, we will use the first option, which is draw rectangle. So let's press on draw polygon. And to draw the polygon, we specify the points on the room we have. So we specify the corner points, like this first point here. And then we specify the second point, which is that point. And then we go there to that point and we press a left click. And we go there to that point and we press another left click. And we go there and press another left click. And we go there and press another left click. And we end at the first point that we have started from it, and also we press a left click. And after finishing the points we have, we will press a right click and then press on close. So if we press on close, we will end the points we have, or we will end adding the borders of the room we have. So we press on close, and that's it. So by that way, we have entered the length and the width of the room we have. So you can see those are the borders of the room, or this is the path of the room. Here point 1, point 2, point 3, point 4, point 5, and point 6 finally. So that's about the length and the width. This is for the area of the room. And finally, for the height of the room, this is, as we learned it before, it will be 3.25 meter. And after that, we press on OK. Very good. So by that way, we have entered the dimensions of the room we have. Alright. Now at that point, we are ready to insert the required luminaires we need. And for now, we will use another type of luminaires, which we have used on the previous couple of tutorials. So we need now to use another type of spot luminaires, as we will use a LED luminaire represented in a spot. And for that reason, we will open the Philips catalog. Here we press on luminaire selection, and then DiaLUX catalog, and then Philips lighting. Then as we will search according to the family code. And the family code for the spot luminaire we need now is DN135P. So this is the family code. We go there and choose it. And that's it. Here we can specify the first housing type, which is DN153P D165. And here there is no distributor. And for the number of lamps on the luminaire, we have two selections. Each of them has only one LED lamp. So this is 1 times LED and this is 1 times LED. And what it changes only is the color temperature. So the color temperature for the first luminaire is 3000 Kelvin and the color temperature for the second luminaire is 4000 Kelvin. While the color rendering index for the first one is 80% and also the color temperature for the second one is 80%. Here, if you remember, we have illustrated this number on the previous tutorial, 830. So let's specify the first one, which has a color temperature of 3000 Kelvin. And that's it. You can see this is the shape of the luminaire we need. It's a recessed luminaire, which will be a suitable one for the suspended ceiling we have. And you can see here, those are the technical data of the luminaire we have. It has a total output lumens of 1000 lumen and its light output ratio is 1. And for that reason, we find that the luminous flux to have also a value of 1000 lumen. As if we divided the luminous flux over the total lumens, it will be 1000 over 1000, which gives us exactly a percentage of 1, which is the light output ratio. And then for the power of this luminaire, it's at 13 watt. Very good. Now we can press on add to add this luminaire. And then we press on close to go back to our design. And at that point, we need to specify the lux required for this conference room or for this meeting room. And here we jump to the IEC code. So that's the IEC code for the required values of lux. Here we can search for conference. That's it. You can find here we have the conference room, or we can suppose also that this room we are working on is a general office. So anyway, if we suppose it to be a general office or a conference room, it will have the same value of the recommended value of the lux, here from 300 to 400 lux and here from 300 to 400 lux. And as we learned before, it's recommended to work on the recommendation values on the second column, not to work on the first column values, which is the maximum standard values. So those are the most common values from 300 till 400. And for us now, we will choose the value of lux to be 300 lux. So our aim now is to design a lighting system for our room that achieves the required value of lux of 300 lux. Very good. Now let's go back. Here to insert the luminaire, we will press a right click and then insert luminaire. And because this is an official design, so we will insert a field arrangement or a matrix arrangement. Here we press on field arrangement, and for the required luminaire, we will choose this luminaire which we have just picked from the Philips catalog. Here its luminous flux, as we said, is 1000, its power is 13 watt, and for the correction factor as we will set it to be 0.8. That's it. Now for the mounting or for the number of luminaires, we access it. And then we set the required average value of the lux to be 300 instead of the 500. And then we press on suggestion for the program to suggest an arrangement or a number of luminaires for this room. Here it suggests us that we need 4 rows and each row needs 6 lumineers. So it suggests us that we need 4 times 6, which is 24 lumineers. Now we will try this suggestion by pressing on insert. Very good. You can see those are the required values of lumineers we need. But you can ask now, how the program inserts some lumineers that they are lays outside the room borders. You can see those 2 lumineers lays outside the room borders, and those 2 lumineers are inserted on the wall of the room. Here we say that the program neglects any lumineers which lays outside the room borders, or it neglects any lumineers that lays on the wall area of the room. So for those 4 lumineers, the program will neglect them as they lays outside the room border. Or we say that those 4 lumineers appears only on the shape of the design, but they will not be included in the design anyway, as they are not added in the calculations of the lux value. Hence, those 4 lumineers are not included in the design anyway. And for that reason, you find that those 4 lumineers appears on the gray color, so their color is gray here, which means that they are not included, while the other lumineers here appear on the blue color. This is because they are included in the design. So the lumineers which are included in the design appears to be blue here, while the other lumineers which are not included appear here in gray. Very good. Now to start our calculations, we press on this calculator tab and we include the meeting room, which is room 8. So we press on this tab and this press OK. Very good. The calculations are made now. That's good. You can see this is the design of our room we have in the 3D. Here if we go there, we will find that this is the design we have. And then we press on the single sheet output to check the results we have got. Here for room 8 and press OK. Now we press on view full size and go down. As you can see, we have here an average value of lux of 336, which is larger than the maximum allowable value of the maximum lux, which is 300 plus the 10%, which is 30 lux. So the maximum allowable value of lux must be 330 lux, while the value which we have got here is 336, which is larger than the maximum value as we said. But for you note, it's 0.68, which is an accepted value. So our aim now is to decrease the average lux a little bit, not to exceed the maximum value of 330 lux. And for that reason, we need to decrease the number of lumineers we have. This is to decrease the average lux. So we close this tab and go back to our design for room 8 or for this meeting room. And now we go back to the selection mode and then we select any lumineer we have in our design. After that, to change the number of lumineers, we press on positions. So you can see here we have 4 times 6, which is 24 lumineers. So we need to decrease it. Suppose we need to decrease it from 24 to 21. And if we need to make a matrix of 21 lumineers, it can be 3 times 7 lumineers. So we type here 3. And then for the lumineers per row, we will make it to P7. That's good. Then we press on yes. Here if we have those number of lumineers, which is 3 times 7, this gives us a total number of lumineers of 21, which is smaller than 24 lumineers. Very good. Now we start the calculations again as we have made some modifications. So we press on start calculation and then press OK. Very good. Now we press again on the single sheet output. This is for the meeting room. And then view full size again. And go down. You can see here we have the average lux of 295 lux, which is an accepted value also. This is because the average lux here must have a tolerance value of plus or minus 10%. So it can range from 270 lux to 330 lux, as it lays in our allowable range or in our available range. And also for you note, it's about 0.59, so it's an accepted value also. Very good. So by that way, we have made an accepted design, and then we press on close to close the single sheet output. And now we need to change the room name, so we will make it to be the meeting room and press OK. That's it. So this is the room we have, and this is its 3D design. Here we can rotate it by pressing rotate. And you can see those are the luminaires we have. Those are some spot luminaires, and those spot luminaires are of the type LED. And this is the extension of the room, which made us to make it a polygon room, as it has more than 4 borders. Very good. So that's about this tutorial, at which we made another design for another type of room. Hope that's clear right now. Thank you for watching, and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we will illustrate another case of the lighting system design to cover the different ideas which we can face during the designing operation. So let's go ahead. Now suppose we need to explore another type of rooms in the hospital layout. Here, as we are working on a hospital, so let's pick a room which is related to the medical category. Here, if we go there, we will find that we have a room like this one here. So we will find that this is an operation room, as the furniture of this room refers to an operation room. You can see this is a bed which the patient relaxes on, and those are some medical equipments that the doctor uses through the operation on the patient. So we can specify this room as an operation room on the hospital to work on. And now what we will do is to press on insert new room, and then we go up to specify the dimensions or to specify the borders of the room we have. Here we go there to our room. That's it. And then we press a right click, and then we press on draw rectangle. This is because this room consists only of 4 walls, so there is no need to draw a polygon. Here we draw a rectangle, and we start drawing the rectangle from that point. Here, this is the first point of the room we have, and then we go there up a little bit until that point, so it will be good to end at that point, for example. Very good. So that's for specifying the length and the width of the room. You can see its length is 5.1 meter and its width is 4.6 meter. Now for the height, we will set it as we used to be 3.25 meter, and that's it. Here we press OK. So that's for the dimensions of the room, its length, width and height. After that, we are ready now to insert the luminaires we have in our room. But we will illustrate now a new case of the lighting design, at which we have more than one type of the luminaires, or we have more than one types of the lighting luminaires. So it's not necessary to have only one type of the luminaires in the same room, as we can insert more than one type of luminaires. And for that purpose, we will use 2 types of the luminaires. The first one is the luminaire which we have used on the previous tutorial, which is the spot luminaire, which has a family code of DN135P. And the second type of luminaires which we will use is another LED luminaire, but it's not a spot one, as it's a 60 x 60 cm LED luminaire. So it takes the same shape of the 4 x 18 fluorescent luminaire, as it has the same dimensions, as each of them has dimensions of 60 x 60 cm. But this time we are working on a LED luminaire. So let's see how can we make this combination of the 2 types of the luminaires. But before that, we need to check the required lux value for this operating room on the hospital. And for that purpose, we can open the IEC code. Here we jump to the IEC code. That's it. This is the IEC code for the lux required levels. Now we search for the hospital. Here we type hospital and press enter. That's it. Here you can see this is the hospital main category. And under it, we have some types of rooms that is related to the hospital. But for the room we need an operating room. So if we go down, we will find that exactly we have here an operating room. And for the required lux, it's 400. So this is the maximum level of the lux required. And this is the standard value. And we have no recommendation value. So as we have no recommendation value, we will work on the standard value, which is 400 lux. Now we go back to DiaLUX, and at that point we are ready to get the luminaires we need. So we press on luminaire selection, then DiaLUX catalogs, then Philips catalog. Now we will search according to the family code, and we will search for the required 60 x 60 lead luminaire, and for its family code it's known for us to be RC180P, so we type here RC180P, that's it, we drag this tab down. Then the family code of this luminaire is known to be RC480P, so we type here RC480P or P, that's it, we drag this tab down and select it. Very good, you can see this is the lead luminaire which we need. It's one-time lead, and this is its color rendering index to be 80%, and this is its color temperature to be 3000 Kelvin. So we will select the first one here, or the first selection, and here for the distributor we will select the first one. But for the housing, as we need a 60 x 60 luminaire, so we go down. Here we go down until we find that this is the dimension 60 x 60. We select it. Very good. You can see this is the luminaire we have. It's a recessed luminaire which is installed on the suspended ceiling. Here its lumen is 3500 lumen, and its light output ratio is 1, and for its power it's 33 watt, and it has no ballast, and this is its polar curve. Very good. Now we will press add. Here we have added our required luminaire. Now we press on close. After that, we are ready now to insert this lead luminaire in our room. Here we press a right click and then insert luminaire. And now we will insert a field arrangement in our room. So we press on field arrangement. Now we drag down to select our required luminaire. So this is the required luminaire, which is 60 x 60. We select it. Here this is the lead luminaire. And then for the mounting, we can select the number of rows to P2 and the number of columns or the number of luminaire per row to P2 only. Here we press 2. So by that way we will insert only 4 luminaires in that design. And then we press on insert. Very good. You can see those are the required 4 luminaires we have in our room. And now the next step is to insert the second type of luminaires on the same room with the first type. And for that purpose, we will use the second type of luminaire which we have used on the previous tutorial, as we said, which is DN135P. And for that, we press a right click again and then insert luminaire. And at that point, we will not insert a field arrangement, but we will insert an individual luminaire. And this is because if we inserted the new luminaire to be on a field shape, the new luminaires will clash with the previous luminaire, which is 60 x 60. So the new luminaires may be inserted on the same positions of the first luminaire. And for this reason, the right arrangement for the second type of luminaires is to be an individual arrangement, as at that case we specify the position of the luminaire and we control them individually one by one. So if we need to specify the positions of the luminaires manually ourselves, we will use the individual arrangement. Here we press on individual luminaire. That's it. Now we specify the luminaire type to be the spot that we have used in the previous tutorial. So this is the required spot. We select it. Very good. Now we press on insert. As you see, we have inserted only one luminaire here. And now if we need to insert more than one luminaire, what we will do is to select this luminaire and press Ctrl C. This is to copy this luminaire, and then press Ctrl V to paste it. So when pressing Ctrl V, you can see this is the new luminaire. We have inserted it here, and we can change its position as what we need. And this is the benefit of the individual arrangement, at which you can insert the luminaire at the position you need. So we can insert it here, and then we can try this operation again by selecting this luminaire, for example, and press Ctrl C and then Ctrl V. So we have inserted a new luminaire. Here we can add it to be at that position, for example, or here a little bit. So as you see, we insert the luminaire at any position we need. We can drag it here a little bit, and then we can align this luminaire to be aligned to the first one, and then we can align this luminaire also. Here those 3 spot luminaires are aligned on the same line. Now we can copy that one again. Here we press Ctrl C and Ctrl V, and we can make it to be at that position, for example. Here we can put it here. Very good. Now we can insert another lumineer. So we have inserted here 4 lumineers, those 4 ones, but we need to insert a 5th lumineer. So we press Ctrl C and then Ctrl V. And then we drag this lumineer down. And we can put it at the position. So this will be a good position. Very good. You can see we have inserted here those 5th spot lumineers, and this is in addition to those 4 LED lumineers. So we have here 4 lumineers of the type 60x60, and we have 5 lumineers of the type spot. Now the final thing we need to do is to check if this design is a wrong one or a right one, as we need 400 lux for this room as we have got from the IEC code. So what we will do is to press on the calculator tab, and then include all lumineers, and then press OK. Very good. Now what we will do is to change the name of this room. Here we change its name to P, the operation room. Very good. Now we press on the single sheet output to see the results which we have got. It's for the operation room, and press OK. Then we press on view full size and go down. Very good. You can see we have here the value of the average lux to P 500 lux, and U naught is 0.7. So U naught is an accepted value as it's larger than 0.4, but for E average it's larger than the maximum required value, as the maximum required value, as we said, it's needed to P 400 lux. So 500 lux is larger than the maximum value. So we can make some modifications on our design. Here we close that tab and go back to our room. Now what we can do is to select that lumineer and delete it, press yes, and then select that second one and delete it. And after that we can make our calculations again by pressing Store Calculations. This is because we have made some modifications, and then press OK. So the calculations are done again, and then we press on the single sheet output for the operating room and press OK, and then view full size and go down. You can see U naught is still accepted as it's 0.7, but E average is still larger than the required value. This is because we have got 460 lux, but the maximum value is 400 with 10% increase, which is 40 lux. So 460 is larger than the maximum required value. Now we close again. And what we will do now is to delete another lumineer. So we can delete this lumineer in the center. Here we press on it and press delete, and yes. Very good. Now we recalculate again and press OK. And then we press on the single sheet output again for the operation room and press OK. And then we view full size and go down. Very good. You can see we have achieved it. We have got an average lux of 436, which is smaller than the maximum value of 440 lux. So we haven't exceeded the maximum value. And for U naught also, it's an accepted value of 0.73. Alright, now we can close that tab and see our design. Here, this is our design. We can rotate it. Here, those are the 4 LED lumineers, and those are the 2 spot lumineers. So by that way, we managed to make a design that has more than one type of lumineers, as it's not important to have only one type of lumineers. Very good. So that's about this tutorial. Hope that's clear right now. Thank you for watching and see you next tutorials.